This program is brought to you by Stanford University. Please visit us at stanford.edu.
It's very nice to be here. I see a number of familiar faces, and thank you for the opportunity to participate in this really groundbreaking class, which I have a feeling could lead to more. And Annie, I'm done. Annie did a great summary of what I'm going to talk about. I can go into a little bit more detail. Actually, today my goal, I want to give you a couple of fish, but I also want to teach you how to fish. And what that means is I want to tell you about a couple of examples, and then I want to teach you how you could use PharmGKB in the future in your own particular area of interest to look into potential pharmacogenomic hypotheses. So this is what I'll be doing today, introducing pharmacogenetics a little bit more, giving one generic example, and then going right to cancer, my three favorites, and then drawing a few conclusions. In 1959, Fogel came up with a beautiful definition of pharmacogenetics, which is the role of genetics in drug response. So what this means is that the phenotype of interest is a drug response-related phenotype, and you're interested in the genetics of it, the hereditability of the response to the drug. Pharmacogenomics has been a newer word that has emerged with our ability to make high-throughput measurements. Things like proteomics, microarray expression, genome sequencing itself define pharmacogenomics. In pharmacogenomics, there's a sense that it's a systems-wide study, whereas most of the early work in pharmacogenetics was what you might call Mendelian pharmacogenetics, a single gene affecting a single drug response. And of course, with the sequencing of the human genome, Time magazine, the ultimate source of all information, told us that drugs of the future that are amazing will be based on your DNA and will change your life. And so, okay, fine, that was exciting. And so we're going to try to do that. And in fact, it is a very compelling vision. The vision that instead of giving all patients a one-size-fits-all drug, we're going to actually think a little bit about the drugs that we're giving. Of course, we think about them currently, but we're going to not only think about them, but we're going to be informed in our thinking by their genetics, something which is not routine, although there are some emerging examples. So you know all this, that we have about 3 billion DNA bases, that most of it, the 99% number is getting very fuzzy because of Craig Venner's recent article, so somewhere above 90% we all share. But that remaining amount makes a difference, and one of the main sources of differences, but not the only, are SNPs, single positions where you get a single base change, and if you call the cutoff to be 1%, there are about 3 million of these or so in the human genome. Of course, there are many other polymorphisms, repeats, translocations, transversions, transpositions, and they all can be potentially important. And as a side effect, there are many, many possible human genomes, and I've done some back-of-the-envelope calculations, and I can assure you we've only seen a small percentage of all possible humans, which is probably good news. And so for pharmacogenetics, the basic value proposition, if you will, let me get my pointer, is that something like this, here's a polymorphism where a T is in one chromosome is a G in another chromosome, can be correlated to observable traits like whether you respond well to a cholesterol medication or a cancer medication, or whether you don't or have terrible side effects. So to summarize, we want to understand, and this is exactly what Annie said, understand how genetic variation leads to variation in the response to drugs, and it is a promise we have made. And cancer is an important early application area for pharmacogenetics because the value proposition is very clear. These are high-stakes prescribing decisions because of resistance and response of the cancer to its treatment. Your first shot is often your best. And so there's a situation where you're willing to think very hard about the medical regimen before you act. There's other debates about things like in general